Hello everyone and welcome to today's discussion on lab grade flooring. My name is Tom Ricciardelli. I am the president of SelecTech. Our company makes lab grade flooring. I'm also the chair of the SEFA lab flooring committee, so I was involved in creating the standard that we're going to cover today. Before I do that, I want to talk a little bit about who is SEFA. Hopefully many of you are aware of who they are. But SEFA stands for the Scientific Equipment and Furniture Association. Their main purpose is to create basically lab-grade standards to be used in the industry. And that will allow users to properly specify and use appropriate equipment in labs. SEFA consists of volunteers like myself. We have incredibly broad expertise, including manufacturers of products like myself, end users, people that own and use labs and use equipment, people that test equipment, companies that specify equipment, so lab specifiers, lab planners, architects, designers, and consultants to the industry. So we've got an incredibly broad expertise, and all of that knowledge goes into creating these standards. So the standards are very good and very useful and very complete. SEFA's been around since '88. And so these standards have been around, many of them for a long time, and they've gone through iterations and improvements. So they are just an incredibly useful resource for anybody involved in the laboratory industry. They publish, as I said, many different standards for many different things that are used in labs. This is a list of everything that is currently available. I won't go through it, but just to give you a sense that they cover a lot of ground, and they have a lot of knowledge about all things labs. Now, the one thing you will notice is missing from this list is flooring. So the SEFA lab grade flooring is what we're talking about here today. It's coming out soon. It's in final review with the board of directors at SEFA. The committee has done its work in preparing the draft. It's got a lot of incredibly useful information in it. Its purpose is to provide a comprehensive guideline of laboratory flooring. So not just the criteria that would be used to specify a floor, but what is lab grade? What is laboratory flooring? What types of flooring are used in labs? And then the criteria you would use to specify it, and then some other considerations like installation and maintenance. So it covers a lot of ground. Who would use it? Really anybody involved in a laboratory. If you're specifying a lab, if you're in a lab, or if you're selling flooring to labs, or if you're making products for labs, this document is a good resource for you. What are we including in this document? Well, of course, the performance criteria. It's sort of front and center. What are the things that would define what is considered laboratory grade? But then we also had to discuss the different types of labs that this would be applicable to. And not every criteria would be applicable to every type of lab. So there's a whole discussion on that there. We wanted to include a section on environmental considerations because flooring is a building material, and as many of you hopefully know, almost every building material now has some environmental consideration. Is it less impactful to the environment? Is it good for the environment? And so there's a whole discussion on that in this, really with references to the resources that would guide you in that regard. But there is also a section on flooring types available. What types of flooring are used in labs? What's common, what's not common, what are they? That's all in this document. And then finally, it's really general information on basic installation and maintenance considerations of flooring in general, and then flooring in labs in specific. There's a little bit of guidance there. So before I get into what's in the document itself, I wanted to talk a little bit about some of the issues we had to face in creating this guidance document. So first we had to decide what criteria are important for labs. Chemical resistance, static control, other things. So we had a whole conversation around that, what to include. And then again, as different lab types have different criteria. Originally, when we looked at this, we were going to create lab criteria, period, across the board. And really, that was clear that wouldn't be all that helpful because not all labs need all of these requirements. So we created a really nice matrix to line up the requirement with the type of lab. And then what types of flooring are used in labs in general? So again, just a description of different flooring types, what they are, how they're made, And that's in there. So when you're specifying floor for a lab, you have a really good understanding of what it is that you're choosing. So with that, I wanted to turn to the criteria that we specified in this document. This is sort of the meat of the document. These are the criteria that you would consider specifying when you're specifying flooring for a lab. So top of the list, chemical resistance. Next down was static load, which helps address its durability. Ease of cleaning is something that people refer to in the industry, but there's no clear definition of it. We provide that. Impact resistance, again, another durability characteristic. Slip resistance, because of the nature of the foot traffic and whatnot in the laboratory, is important. Dynamic rolling load resistance for labs that might have a lot of moving loads. Bacterial resistance for biological labs. Static control for labs that have electronics sensitivity. Off-gassing, which is really an environmental characteristic, but can impact clean rooms. And then spill containment, which is important in labs that you don't want spills getting under the floor. You'll notice in all of these we have, except for the bottom one, we have a specific test method so that you can test the product for that characteristic with a number or limit. Makes it very easy to specify a product. This does not exist in the laboratory market today. So this document creates this guideline, this characteristic, these specifications. Spill containment is a physical characteristic that you describe, but it's very clear what it means, and I'll get into that later in the document. I will go through all of these in more detail because they're so core to what this document does. Before I get into those characteristics in detail, I wanted to cover just some of the sort of the more general sections that were included in this document, and then we'll get into the detail of the characteristics after that. But one section we included was installation considerations. So basic things like how floors need to be prepared. We provided references to industry guidelines for installation by material type where they are available. Nuances to be aware of by specific material type. There are some things, and these are particular to labs. And then we make a recommendation, always refer back to the manufacturer's instructions. So you want to keep all of that in mind for installation. We do something very similar in the document for maintenance considerations. There are some basic things you need to keep in mind. Disinfection is somewhat unique to laboratories, although it could be applicable to other industries. We provide we reference industry guidelines where we have them, where they're available. And there are some cautions we put in there that are specific to laboratories. Finishes in particular. Floor finishes are very commonly used to protect floors throughout the industry. And there are some situations where you have to be very careful when you use them in labs. Clean rooms, for example, some clean rooms you can't use finishes because they emit particulate, which is not good for labs. If you use the wrong finish on a static control flooring, you'll ruin its performance. So those notes are in there. And again, always refer back to the manufacturer's instructions. Environmental considerations was another section we included. Important for choosing, like I said, any building product. This section kind of gives you a very good overview of what those considerations are and where you can go to get more information. So basic things like what's the product made of? Does it have recycled material, recycled content? Is it recyclable? Is it free of what's considered red list materials that are bad for the world? Is it low VOC, low emitting? Is it going to last a long time, which gives it a better life cycle value? And is there documentation behind that? You're familiar with HPDs and EPDs. So these are things you would consider, and this section of the document just basically describes that. And then in terms of environmental ratings, the LEED system, the International Living Furniture Institute has a program called Declare, which defines how things are reported for different materials, the Mindful Materials Database, and the cradle-to-cradle system for evaluating a product's impact on the environment. So really just a brief description of these things and point you in the direction of getting more information. As I mentioned earlier, the document provides a very detailed description of the different types of flooring that are commonly used in labs. As I mentioned earlier, we have a pretty diverse group on the team, end users, existing specifiers, and we had a broad discussion about what types of flooring do they see in the market, what's used, what's effective, what's not effective. And this is a pretty complete list. So it includes vinyl flooring, tile and sheet goods, rubber, tile and sheet goods, linoleum, vinyl composition tile, which is also known as VCT, has been used in the industry for a long time. Ceramic, porcelain, quarry, obviously very hard products, very durable, have value in the market. Polished concrete is being used more and more, we're seeing. Can be a very effective surface for a laboratory. And then simple coatings and finishes like paints, sometimes used in laboratories. Resinous floors, which used to be called epoxy floors, but now there are other materials like polyaspartic and polyurethane that are used that are similar, so now we call them resinous floor systems. They provide a completely monolithic sealed floor, very useful in very demanding biological labs, for example. Interlocking flooring is now sometimes used in labs. It provides benefits in terms of portability, reconfigurability, and there are some systems that can be made liquid tight. So it describes those and those considerations. Access floor systems, which is really kind of a subfloor system, some of you may be aware of. They're very robust, can handle high weights, sort of a fake floor that goes in first. And so you can run your utilities, HVAC, water, gas underneath. Very useful if you want a reconfigurable, flexible lab space. So they're seeing more value in the industry. And this document describes them and the considerations you have to take into account for a laboratory. Also a description of what static control floor systems are, how they work. It's a very, sort of unique application in the industry. And this gives you a good description of what that is. So again, this section provides a pretty in-depth understanding of what different flooring systems are that are used in laboratories. So if you're specifying something, you'll know what you're specifying. So then we had to, again, decide which types of labs we were going to try to categorize, because as I mentioned, not every criteria is relevant to every type of lab. So we wanted to have a good representation of the types of labs you might have, and then you can decide which criteria are needed for that lab. So we looked at biosafety, general chemistry, organic chemistry, physics labs, clean rooms, vivarium, engineering, even workshops, electronics labs, trace metals labs, computational labs, and K through 12 labs. So somewhere in that list should be a description of or something that's similar to what you're designing and defining. One thing we point out to end users is, take a look at what you're doing in the lab and try to line it up with one or even more of these types of labs. And then when you go to line out what criteria you need, you might have a hybrid of criteria or a combination even. So we really want the end user to think about what's happening in the lab and start from that level and then try to figure out which types of labs address that. So that's kind of the layout. And as I said, I wanted to get into more detail on what the characteristics or the criteria we defined are and how we define them. And so the first one was chemical resistance. SEFA has a test that's very similar to the standard stain resistance test that's used in flooring, but includes a whole lot more chemicals, and many of which are much more demanding than the chemicals that are in the standard flooring chemical resistance test. So the SEFA 49 test, it exposes it again to 49 different chemicals, some of them very challenging in terms of how they impact the floor. But it's a rating system from 0 to 3, 0 being no effect, 1 being slight visual effect, 2 being a more noticeable visual effect, but no physical impairment of the product, and 3 being a a very distinguishable physical effect and possible deterioration of the physical performance of the product. So from 0 to 3, we define what lab grade is that a flooring material can have no more than 4 level 3 conditions. So it can't really basically fail to more than 4 things, and it could be considered lab grade. The next characteristic we looked at was static load limit. This is sort of a test of the ability of the floor to hold things, so a durability test. There's a standard test in the industry, ASTM F970, very easy for flooring manufacturers to test against this and report it. A standard test requires a floor material pass a load of 250 psi. That we consider to be a good limit for any lab. If a floor can't meet that, it's really not appropriate for a lab. The next test we looked at was ease of cleaning. Now, you may see ease of cleaning described in requirements for products, flooring products even, in the industry without any definition. Must be easy to clean. That's not very helpful in our opinion, so we wanted to give it a defined test. And there, in our world, there is one. It's used on lab countertops, which is a very useful test. It's NEMA LD3-3.4. Tests a variety of staining agents and then whether they can be cleaned off using various cleaners. Depending on how that all goes, it's given a score for each material, for each cleaning method. The score ranges from 0 to 75, with 0 being the worst, 75 being the best. The requirement for countertops is that they pass a minimum score of 20. And so we use that same limit for flooring. Impact resistance was something else we considered in labs that might have things being dropped and whatnot. Turns out for impact resistance, it depends on what it is. There are different tests. So we define 3 ASTM tests that are relevant depending on what type of material it is. We laid all that out. Each test has a slightly, well, 2 tests require you pass a minimum of 100 inch-pounds, which is a measurement of an impact. And the other test for sheet vinyl was a pass test. So we require that for if impact resistance is going to be a requirement for your lab, that you must pass these limits. Slip resistance we felt was important. Nature of labs is people are on their feet. You don't want the floor to be slippery. There is a standard test method that's used in flooring. So we referenced that, and we required a minimum, they call it a coefficient of friction, which is a measurement of its slip resistance of at least 0.5. The higher the number, the more slip resistant it is. There are products in the market that are designed specifically as quote-unquote anti-slip, which would have a number much higher than 0.5. So 0.5 to us was a sort of a minimum requirement that a product should have. Dynamic load resistance gives you an evaluation of the durability of that product for rolling loads, and many labs have things that are rolled across them. There's a good ASTM test that's for resilient flooring. For some of the more harder surfaces, porcelain, quarry, tile, things like that, there's no test, but they really aren't subject to failure to rolling loads because of the nature of what they are. So we felt that this test would be adequate. Certainly if you have a resilient material, you'll want to pass it. If you're using like a porcelain tile, you could subject it to this test, it would pass. It would sort of be a no-brainer, but if you want it to be rigorous, you could have insist that the test be done for it and include it into your criteria. Bacterial resistance, as I said, is something we felt was important, and particularly for biological labs. There is a test, ASTM G21, that tests whether something grows fungus on it or not. Sort of a simple description of it. It's a rating system from 0 to 4, 0 being nothing grows, to 4, lots of stuff is growing, so it's a problem. It's really only particular or relevant to the biological labs, the BSL and the vivarium. Those labs have a standard, and we just basically reiterated it here and referenced it. So for the least critical labs, the levels 1 and 2, it's got to be it's got to be at least a 2, couldn't be a 3 or a 4 in terms of growth. And for the most critical labs, the levels 3 and 4, it has to be a 0, no growth shown. So again, we just sort of mimic that requirement. ESD, static control, is another thing that is in the industry, really relevant to electronics handling. You might use it in a computational lab. And there's a very good standard in the industry. I should say, as an aside, I'm the chair of the flooring committee at the ESD Association. They write these standards. So I'm very familiar with what these are and how they work. It's very definable. There are tests of these properties. So if you are purchasing and specifying a static control flooring, the manufacturer of that product will have these numbers reported, and you need to meet certain requirements. They're very well defined, pretty standard, simple. One thing I want to point out is that for the floor system itself, you will report the resistance of that floor. It has to be below a certain level, 1 times 10 to the 9th ohms, to pass the S20.20 standard. But one thing you have to be aware of is that in order for a floor to control charge on people, which is mostly what you're concerned about, the person has to be electrically connected to that floor. And the way they do that is with static control footwear. So number one, if you're specifying a static control floor, you probably should be specifying some type of footwear. Number two, you want to make sure that that footwear works with that floor. And it's weird, but it doesn't always happen that way. So you'll have a footwear that's rated and tests well as a footwear, and a flooring that rates and tests well, and for some reason they don't work together. So you're going to want to make sure that the end user understands that they need to test the footwear with the floor once it's installed. And if it doesn't work, you can always select other footwear. So footwear is easy to change, and there are many options in that market. And then again, there are tests for all that. And we describe all that in this document. So again, we're giving the end user very clear guidance on what it is they're specifying. Off-gassing, as I mentioned, is a requirement that really kind of came out of environmental ratings. You know, it's in the LEED program, products are recommended to be meet the California Protocol 01350. You'll see a lot of flooring products say that they're floor score, and floor score is a test that's it's managed by SCS, which is a very reputable, rigorous testing authority, laboratory, and they basically test to the California Protocol, but they do it with their own protocol or of managing the samples and making sure it's all done well. So and reliable. So again, you're going to see floor score on a lot of products. You may also see MAS Green Certified is another one that basically again uses the California Protocol, and all of those are valid. And they'll reference that they are using the California Protocol for VOC emissions. So those are all the requirements that we've included in this, and you can't read this because I know it's too small, but what we wanted to do, we defined the criteria that we felt were relevant. We defined the labs that they would be relevant to. And as I mentioned, not all labs really should be required to meet all of those criteria. So we created this matrix where we lined up the lab type with the requirements, and within each block, it lists what the requirement should be. So if you were going to be building a BSL1 lab, you would just go down the column and pick out those requirements that are listed, and that would go right into your specification. Now, as I said earlier, we want the end user, lab owner, lab planner, lab designer, to define what it is that they're doing in that lab, and then pick one or maybe more of these columns that would fit under, and then look at those requirements. You may also look at what you're doing within any particular column and say, I don't need one of these characteristics. So for example, in computational, we recommend static control flooring. In a computational environment, if it's all computers, you don't necessarily need static control. It's helpful. You might decide that you don't want to specify that for that. application. So again, we leave this discretion to the end user. If you want to just keep it simple, you look at your column, you pick your requirements, and you put them into your specification. It's very straightforward. We think that this grid is it's sort of the crux of the whole thing, and it gives you everything you need in sort of one page. Certainly the starting point. The last characteristics, which I haven't talked about yet, was spill containment. And like I said earlier, there's no real test standard for this. You kind of have to look at it as a physical requirement. And there's sort of 4 levels of what we call spill containment seamlessness. One is generally impervious to liquids. Most products will meet that. Glue down products, cemented down products. As long as they're designed sort of without leaking. And as I mentioned earlier, there are some interlocking products that can be generally impervious to liquids. They're made for it. The next step up would be seamless or welded seams. So the product itself has no seams, so like a poured resinous floor. Or if it's tiles or even sheet goods, where there are seams, they're physically melted together with a weld. Lots of sheet goods can be done that way. Tiles can be done with that, a lot more work, but it can be done. And those are considered seamless and liquid tight, of course. The next level up would be that you would run that up the wall. So that's called the integral cove base. In a normal installation, you'd have the floor, and then you'd have the little trim at the bottom, which is the cove base. If you needed to sort of this next level of liquid tightness, you would run the product itself up the wall, and it would create its own cove base, and that's seamless. So there's no potential for penetration through that. The final, most rigorous case in all of this is monolithic, and that's where you have a resinous floor. It's poured, it covers the entire floor, and it's run up the wall to create its own integral cove. So it's monolithic. For the highest level of biosafety, that's required. And again, as I mentioned earlier, they have the biosafety industry has a document that describes this, requires it, and we simply refer to it. And so the other thing that's slightly different about this grid versus the other one is, instead of talking about lab type, we talked about, it's sort of a little bit of a hybrid with biological on one side, and then what are you doing in that lab? Are you handling chemicals? Are you handling chemical waste disposal? Do you have wet processing? Those things, and that could be in any type of lab, really. So if you're doing those things, you need to consider these characteristics. If you might have a chemical lab that doesn't have those characteristics, so you wouldn't necessarily need this and still be a chemical lab, so to speak. So we handled this separately. And it's all in a grid, so it's very easy for the user to refer to it. Do I have this type of lab? Am I doing these types of processes? These are the things I need. So there was a lot there. In summary, I kind of gave you an overview of who SEFA is and what our soon-to-be released lab grade flooring standard is, what's in it. A lot of detail on the requirements that flooring would need to have to be considered lab grade. The different types of flooring that are available to an end user to choose from, the different types of labs that you would try to put your characteristics within, and then some other considerations that we think are important when choosing and specifying lab grade flooring. So thank you so much for listening. I hope this was helpful. Again, there's a lot of information here. If you want to contact me, this is my contact information. Feel free to reach out. And I would highly recommend, if you're in the lab market, you go to sefalabs.com, look at what they have. Like I said, there's a lot of very good information there. So again, thank you very much. I hope this was helpful, and enjoy the rest of your conference.